Hi, Sierra. I've got the assignment question here that you had sent me. So, if I am interpreting this correctly, then he's giving you rates of change here, which means that these are the derivatives of the original functions. And so the actual calculation for CO2 emissions would be your integral of this, and we'll call it capital P of T. That would actually be the formula for calculating the amount of emissions, because these are rate of change formulas. And so here again, if we integrate C of T, because that's actually the derivative, the rate of change of the carbon spending, then we would get the amount of carbon spending as a function of T, which is days in the month, okay? So that's something that we need to understand right from the beginning. And because of the way that this is pieced out, for the first 5 days, it's a constant, and then for any days greater than the 5, starting on the 6th day, it follows this formula. And so when we integrate, what I would do is I would integrate over 0 to 5, and that would just be of the 100 with respect to T. And then I would integrate from day 6 on to, I think there's 30 days in November, so up to 30 of the 240 T to the 0.2 dt, like that, because it's two separate functions. They're piecewise functions, and so they apply for certain amounts of days, like that. So that's what I would do to start off with for the first question. So if we integrate, I won't go through the whole thing because this is a marked assignment, but let's just get a start on it so you know what to do next, okay? So for 100, it would be 100T, and we're going to evaluate that over 0 to 5. And then for 240T to the 0.2, we would have to go backwards and add 1 to our exponent. And then that would mean 1.2, so we'd have 240 over 1.2, so that would be 20, no, that would be 200, 200T to the 1.2, and we're going to evaluate that over 6 to 30, okay? So I'll stop there and let you evaluate that, so that then you're going to have the number of number of tons of carbon that's being produced. Okay, that'll give you that total. And then what you're going to need to do to compare it and see what the difference is go back to the C of T formula. Okay, if we take that derivative that we were given, let me just move this all up a little bit. Okay, so our derivative is that formula that we're given here, which is 5,000. We don't have to worry about the 0. And so if we integrate that with respect to T from 0 to 5 days, because after that it's just 0 if T is greater than 5, then that gives us 5,000 T, and if we evaluate that over 5 to 0, it'll give us 25,000. And so that's how much money we've spent offsetting. And for each $50 we spend, that's offsetting 1 ton, right? And so how many 50s go into that? 500. And so we're offsetting 500 tons of carbon, and we want to compare that to what we get up here in terms of how much we've actually produced. Okay, and that would get you through all of question 1. Okay, for this one, trying to figure out exactly what they're asking for, because this is worth 10 marks. Find a function of days past t since November 1st, giving the gap between our polluting and believed CO2 equivalent, given that we emit 50,000 tons of CO2 and spend 1,500,000 on carbon offsets on November 1st. Okay, so we are producing 50,000 tons. And we're offsetting this amount of money, and each $50 offsets 1 ton, right? I think that was what they gave us before. And so if we divide that, we can take off a 0 and a 0 here. 1, 2, 3, 4. 2, 3, 4 zeros. Okay. So that's 30,000 tons that we're offsetting. Okay. And so on November 1st, if we want a function for the gap between them, the gap would be, we're producing 50,000 and we are offsetting 30,000, so there would be a 20,000 ton gap. So there's no information given after November 1st, though. So does that mean that the gap would just stay the same? That doesn't feel like it's worth 10 points. I'm wondering if you could clarify that one with the prof or the TA, or if you have a Discord or something in your class, because it feels like we're missing some information here. Because right now, that's all I can do with it, and I think they're asking for more than that. Okay, for this one, I think what we're looking for here is the total P of T that you solved for in part A, and I didn't go through and solve that, so I don't have that number for you. If you take that, which is that's the total for the month, right? Because that was over the 30 days. So if we have the total for the month and then we divide that by the 30 days, that would give us an average daily emission. And again, that doesn't seem like it's worth 5 marks. But maybe it is. I'm not sure. Because you already have that number from 1A, right? If this is what's, if we're still going with that information. And so your average daily emission is just that number divided by 30. Okay, I can't see anything else that you would do there. Okay, so for question 4, again, you're going to need the answer from part 1A, because what you did for number 1A was you calculated the difference between the offset and the purchase back. So was it 5, how many tons of, what did we get, 25, what did we get for that? I think we got 500 tons, right, purchased in offsets. And then we didn't calculate how many tons we had produced, but it was going to be greater than that. Okay, so let's say it's 15,000 or something. That's not the answer, but let's just say it is. So we would look at the two numbers here, and the difference between them would be 14,500. And so there's actually a significant difference, 14,500 tons more that we're producing than we're offsetting. Whereas when we did part C and we were looking at what happened at the beginning of November, we ended up with a $20,000 offset. And so what's happening there so what's happening there is, if this is what we started off with, no, this is what we ended up with for the end of November, right after the 30 days. So this is at the end of the month. And the one that we calculated in part C was at the beginning of the month, right, on November 1st. And so if those were the numbers that we were working with, and again, this number here is not correct, okay, then I would make the conclusion that we have reduced the gap between our actual emissions and our offsets over the course of the month, so that the rate of change of the produced carbon is decreasing throughout the month, because the gap is closing. And I think that's what they're looking for you to say there for number 5, or for number 4, sorry, is that you've got a smaller gap by the end of the month than you did at the beginning of the month, which means you're closing that gap throughout the month. And so the rate of change of, I guess it's you must be bringing down the production of CO2 over that month, because the cost, like the ones that you're paying for, that's constant, right? And so I think the rate of change of the CO2 being produced is decreasing throughout the month. That's a very weird assignment, but that's the best I can do with it. I hope that helps you get started on it, okay?